In this session, we will introduce advanced data querying functionalities we can implement using aggregates. On this subject, we will cover how aggregates support multiple source entities and the different joins we can have between the data. Then we will introduce what are calculated attributes and how they work in an aggregate. And finally, we will also talk about aggregating records. To learn some of the more advanced querying capabilities, it's important to know or remember what an aggregate is. An aggregate is a visual element of the OutSystems language that allows querying data from entities. Within an aggregate, we can define the source entities, filter data according to a certain criteria, or sort the data as needed. Fetching data from the database is often more complex than fetching data from a single source entity with a simple filter or sorting. Sometimes, to make sure we are getting the correct information from the database, we need more functionality than that. Aggregates have some advanced options that we can easily use in our applications, such as multiple sources, calculated attributes, and aggregation functions. Aggregates support multiple sources, meaning that we can define an aggregate with more than one source entity. In this example, we have an aggregate that has two sources, the customer and the order entities. In the aggregates preview output, we can see the attributes from both customer and order entities. With multiple sources, OutSystems automatically creates the joins between the entities when they have relationships between them, including the join condition. When we have multiple sources, like the customer and the order, we can have three types of joins between entities: only with or without, and with. Starting with the only with, this type of join returns only the records where there is a match between entities. In this scenario, only customers with orders appear in the preview of the aggregate's result, and customers with multiple orders will appear multiple times. In the with or without join, all the rows from the entity on the left are returned, regardless of whether there's a match or not with rows from the right entity. In this scenario, all customers in the database appear in the preview of the aggregate's result, having orders or not. This can be seen on row 5, where we have a customer without an order. Also, customers with more than one order will appear multiple times, as is the case with the customer Bradley Murray. Here the left and right entity make a difference in the result. If the order was on the left and the customer on the right, then all the orders would be returned. The with join returns all rows from both entities, regardless of whether there's a match or not. In this scenario, all customers and all orders are returned, even if they don't have an order or a customer associated with it. Aggregates are translated into a SQL query upon compilation. Regarding joins, the SQL join is what is expected. The left entity is the left entity of the join, and the right entity is the right side entity. The type of join depends on what is selected in the dropdown. A only with join is equivalent to an inner join in SQL. The with or without is equivalent to the left join, whereas the with join in OutSystems is equivalent to the full outer join. The join condition, after the on in the SQL, comes from the expression defined as the join condition, and this can be customized if needed to match more advanced use cases. Aggregates allow hiding columns for previewing purposes. This is particularly important when there are a lot of attributes in the previewer to help us visualize the most relevant ones. This does not affect the output of the aggregate at runtime. Actually, OutSystems has an optimizer that analyzes the columns of the output that are being used outside the aggregate and only fetches those, instead of all of them, regardless of whether they appear in the previewer or not. Aggregates also support calculated attributes. Sometimes there's information that's not directly stored in the database, but with some combination of attributes or calculations, we can easily get that information. So, calculated attributes are custom values that we can compute from other attributes in the aggregate. This creates a new column in the output of the aggregate. These calculated attributes can be created via expressions, which have access to all the attributes in the aggregate, as well as OutSystem's built-in functions and variables accessible by the aggregate. Finally, we can also perform aggregation on the rows fetched by the aggregate. One of the aggregations we can do is to group multiple rows together. For example, we can group the orders being fetched and then calculate how many products are part of that order. To calculate the number of products, we can apply a sum function on the quantity attribute. Since the results are grouped per order, we will get the total per order as well. We can also directly apply these aggregation functions in aggregates. Alongside the sum, there are other functions we can apply, such as the average, min, max, and count. When grouping rows together or using the aggregation functions, only the aggregated columns of the aggregate will be part of the output. They can be easily identified by the columns in blue.